Alright guys, so we're going to talk about lesson 2.5, which is complex zeros and the fundamental theorem of algebra. So the fundamental theorem of algebra says a polynomial function of x with a degree of n has n complex zeros which are real and non-real. Some of the zeros may be repeated. So we've said before, remember, that the exponent, the largest exponent, the degree, tells us how many zeros there are total. Well, that total is our complex zeros, because complex can be real and imaginary. Alright, then the linear factorization theorem says if f of x is a polynomial function where n is greater than 0, then f of x has precisely n linear factors. And we saw that in the previous lesson in 2.4, because we were able to find like our zeros and then we plugged them back in as a factor with x. And so it doesn't matter if I have 10 different zeros, I can plug them all back into a factor with x, and therefore I would have 10 different factors as well. Okay, so the following are the fundamental polynomial connections in the complex case. We already know these, but I'm going to go ahead and list them out anyways. It says the following statements about a polynomial function f are equivalent if k is a complex number. If x is equal to k, then, if x equals k, x equals k is a solution of f. And remember, solution also means it can be an x-intercept, can be a 0, or we could have said it could be a root. Okay, we should actually put that as a solution of f of x equals 0, because it's where our function is equal to 0 to make it the solution. Alright, k is a 0 of the function f, and then x minus k is a factor of f of x. So we saw all of this with real zeros, and so the same thing applies when we're looking at complex zeros, or when we're dealing with imaginary numbers. Alright, the complex conjugate zeros says suppose that f of x is a polynomial function with real coefficients. If a and b are real numbers and b is not equal to 0, and a plus bi is a 0 of f of x, then a minus bi, its conjugate, is also a 0. So we know that complex numbers, or complex zeros, are going to come in conjugate pairs. So if I said that 2 plus I is a 0, then you're going to know that 2 minus I is also a 0. Or if I say negative 4i is a 0, we know that positive 4i is also a 0. So just change the sign in front of the I. Only the I, not the real part of it, if it's like what I put there at first, the 2 plus I and the 2 minus I. It's only the sign in front of the I that'll change.